So an example of a definite integral is when you have, for example, integrating from a to b f of x with respect to x. This is a definite integral because limits are known and shown. Okay, then integrating f of x with respect to x is an indefinite integral because limits are not known. So whenever you have such an integral that is like this, f of x with respect to x being integrated, then we are talking about an indefinite integral. And where you have the limits shown or limits known, then that is called a definite integral. Let's look at examples. Let's begin with indefinite. Let's look at indefinite integrals. So the indefinite integrals that we can take is like x squared with respect to x. If we integrate x squared with respect to x, we say with integration x to power n, if I integrate this with respect to x, then I will increase the power of n by 1. I mean the power of x by 1, so that it becomes x to power n plus 1. Then I divide by the new power, which is n plus 1. So this becomes x squared with respect to x. When we integrate it, this comes with x cubed out of 3 plus a constant. So the other difference between a definite and indefinite integrals is the incorporation of a constant on indefinite integrals. So for definite integrals, do not have a constant because the limits are known. So let's proceed. What about if we had, let me see, if we had 2x minus 4 with respect to x, this is the same as x squared. Okay, 2x squared divided by 2 minus 4x plus c is x squared minus 4x plus c. Let's see if some of you still remember how to integrate this. Integral of 6x squared plus square root of x with respect to x. This is the same as integrating 6x squared with respect to x plus integrating a square root of x, which is x to the power a half with respect to x. And what is this going to be? This is going to be 6x cubed divided by 3, then plus x to the power a half plus 1 divided by a half plus 1, then plus c. This gives us 6 divided by 3 is 2, x cubed plus is x power 3 out of 2, then 3 out of 2. If we divide by 3 out of 2, I will have 2 out of 3, then plus c. That's how we can do indefinite integration. What if you had, let me see, if you had x, I mean the integral of sine of x cos x with respect to x. So this will call you, will enable you, or will force you to use one method, okay? One method which we can say you can use actually use substitution or you can use integration by parts. But the simplest here is to use a u substitution. So I can say let u is equal to sine of x. So that when I say du, okay, will equal to cos x dx. Differentiate u with respect to x, you'll get cos x. So let yourself have du out of dx is equal to cos x. Then you cross multiply, so you'll have du equal to cos x dx, so that your dx will equal to du divided by cos x. So this one will therefore equal to integrating sine x is u now times cos x, then times dx. Dx is du divided by uh, cos x. So I cancel that and that, and this becomes integral of u with respect to u, which becomes u squared out of 2 plus, obviously, plus a constant because this is an indefinite integral. So this is the normal integration, only that we incorporate in a constant. So u is sine x. So this becomes sine squared x divided by 2 plus c. And that's all. So you can do more and more. Let's look at another one. Integrating, um, let me see, 2x into x squared plus 3 squared with respect to x. So when I look at what is inside here and what is outside, I see there is a u substitution. So you can immediately say, because if I substitute for du, obviously I'll have something like this 2x divided by something x, then the x's cancel and I'll remain with only u. So let x squared plus 3 equal to u. So I differentiate this with respect to x so that I have 2x dx is equal to du. In other words, I'm trying to say that du by dx will equal to differentiating this with respect to x. I'll have 2x. So if I cross multiply, I'll have du equal to x dx. So, but what about dx? This will be du divided by 2x. So meaning integrating 2x into x squared plus 3 squared with respect to x will equal to integrating 2x divided by 2x into u squared du. So that and that will go so that I have u cubed out of 3 plus c. But u is known. So this will equal to x squared plus 3 power 3 divided by 3 plus c. And that's all. Now, let's look at integrating x exponential of x with respect to x. This is an application of integration by parts. So integration by parts tells us that if you have, this is actually where it comes from, you have uv. If I differentiate uv with respect to x, I'll have v du dx plus u dv dx. Yes, so that is the product rule. And now if I choose to integrate with respect to x, so integrating d of dx of uv, so with respect to x, we'll be integrating v du dx with respect to x plus u dv dx with respect to x. And what is that going to be? That means this becomes uv, okay? Because I have differentiated uv, then again I've integrated the derivative. So I come back to uv, and this is equal to integrating u v dx with respect to x plus integrating v du dx with respect to x. So always, if I'm integrating u dv dx with respect to x, it will always equal to uv minus integration of v du dx with respect to x. So if I bring in now integral of x, exponential of x with respect to x, I need to let let x equal to u, or let u is equal to x. Why do I make it x is equal to u? Because I know by the time I go to the other side, the x values are going to be reducing, so that I have here, if I have a power of 1 here, the other side I will have something that like a constant. So it will be helping me to reduce the coefficients of exponential that are functions of x also. So that means the u, the x, will equal to 1. So I also need the v, whereby I can say the v, the x, is equal to exponential of x. So meaning my dv is equal to exponential of x with respect to x. I'm doing this very fast because I know you already know how to do this. So meaning my v is equal to, if I integrate an exponential function, I'll still have that exponential function. And therefore, that is if it is just like this. But if it was like 2x, obviously I will have exponential of 2x divided by 2. Okay? Yes. So what about now integral of x, exponential of x with respect to x will be uv will therefore become x, exponential of x, then minus integrating v, which is exponential of x, du dx, which is 1. So this would have reduced my burden. So this becomes x, exponential of x. If I integrate this, I still have exponential of x plus c. Finally, this becomes exponential of x into x minus 1 plus c. And that is the indefinite integral of that.